Hi, Assalamualaikum. My name is Shazali Arifah and I am from Group 9. So today I will be present about our high voltage project, which is design optimization of insulator for improved electrical performances. My group my group members are Muhammad Fahmi, Muhammad Rashdan, Melvisan, and me, Shazali Arifah. So next, these are the agenda for today's meeting. Topic 1 is company profile, topic 2 is design description, topic 3 analysis and simulation, topic 4 is result and discussion, topic 5 is conclusion. Next. So topic 1, company profile. This is our company profile. Our company is Influx Company and our motto is turn ideas into reality. Next. This is the organizational chart. The president is Muhammad Fahmi, and the heads of mechanical department is Muhammad Rashdan, IMS consultant, and next is heads of electrical department, Melvison. So, for me, thank you.
Assalamualaikum, my name is Muhammad Rashdan Razri. For topic 2, design and description. Next. So our project summary is using porcelain rod insulator with 2,175 kilovolt in combination of this. Each disc can withstand 33 kilovolt. So this is our design. Next. So this is cross sectional area of 30 kilovolt porcelain disc. They are Kotaki iron cap, bituminous coating, porcelain iron pin, sandband and cement. Next. So this is specification porcelain long rod insulator. So the spacing of the long rod 317 mm, sheet diameter 170 mm, creepage distance 450 mm. So mechanical falling load strength 40 kilonewton. Power frequency with withstand voltage 80 kilovolt, dry 80 kilovolt, wet 50 kilovolt. Lightning impulse withstand voltage with positive 125 kilovolt, negative 130 kilovolt. Next. So this is properties of porcelain insulator. So the dielectric strength is 63 kilovolt per cm. Comprehensive strength 70,000 kilogram cm square per cm square. Tensile strength 500 kilogram per cm square. Next. So this is our AutoCAD 3D drawing. So as figure on the left, there are each of the 3 kilovolt porcelain this insulator, and the right side the assemble one with this 3D drawing 275 kilovolt porcelain rod insulator. Next. So this is FEMM summary. So our parameter using in FEMM, spacing 550 mm, sheet diameter 140 mm, creepage distance 800 mm. So in FEMM we put the materials of the object. So there have voltage on the FEM 275 kilovolt, ground 0, and the materials air 1 permeability, iron 1 permeability, porcelain 6, cement 12, and water 80. Next. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Fahmi. So we'll continue with FEMM simulations. For FEMM simulation, we do the sketch 2D in asymmetrical. So this is for dry condition. For dry condition, we have 3. three material, which is iron, porcelain, and air. So for each material, we have to put the relative value. So for air, we put it as 1. For porcelain, we put it at for 6. And for iron, we put it as 1. So first we have to match, then we have to conjugate. Next, after conjugate, we can see the voltage distribution. So for upper part, we set it as our ground, and for the bottom part is for voltage supply, which is 275 kilovolt. So as we can see, the upper part, the voltage distribution is low, and the bottom part voltage distribution is high. So to get the graph, we have to choose the line that we want to measure. So we have to choose from bottom to up. We have to set the grid size to 1. This is to get the volt. Sorry. So this is what from top to bottom voltage. So this is the result. And for shed to shed, we have to choose from first shed into the last shed. Okay, this is the result. So next I will continue with the wet test. So for wet test, we add the water droplet at the porcelain surface and cement for the contaminated substance. So for wet water properties, the relative is for water the relative is 80, and for cement the relative is 12. So it's the same step for wet test. We have to mesh first, then we have to conjugate. So it is a same step to get the value of to get the graph of this wet test. So this time we want to get the graph of the magnetic field intensity. So this is our graph. Yeah, that's all from me. Thank you.
Okay, next. For the result, in this test, there are several conditions has been tested, namely dry and wet, and there are 4 graphs was taken for the data observation, which is graph of voltage distribution versus length, top to bottom, graph of electrical field intensity versus length, top to bottom, graph of voltage distribution versus length, shed to shed, and graph of electrical field intensity versus length, shed to shed. Next. Next, the voltage and electrical field strength distribution of HVAC test was simulated using FEMM software. Based on the figure 8.1, voltage distribution for dry and wet is almost same. Voltage distribution is higher at the bottom part, which is 2.750 E plus 0.005, and the lowest is at the top part of insulator, which is 1.375 E plus 0.004. Pink color indicates that the area has high voltage distribution, while yellow indicates that the voltage distribution is moderate, and turquoise color indicates the lower distribution of voltage. Next. Next. As we can see in table 8.2, the voltage distribution versus length top to bottom for both dry and wet condition shows nearly the same voltage distribution under both conditions. This means that the difference between dry and wet condition does not have a significant impact on the voltage level. Next. According to table 8.3, the electrical field is nearly identical across the length of the insulator in wet and dry condition. However, at the end of the length of the insulator in wet condition, the electrical field strength is lower than in dry condition. Although the difference is not significant, but on dry condition has a higher electrical field strength. Next. According to table 8.4, the difference between dry and wet condition is negligible, but there is a slight difference at the line, where the wet line has a vibrating straight line, indicating that the voltage has been disturbed by the wet insulator. Next. For the left graph, as we can see from the table below, the electrical field in dry condition is much more higher than the wet condition. This means that in dry condition, the insulator will work much better than in wet condition. Next. In conclusion, the safety risk assessment need to be considered when handling the HV testing. There are many possible risks that might occur during the test, such as physical, electrical, chemical, as well as biological hazard. However, in HV testing, the most possible hazard that may happen are physical and electrical hazards. In order to reduce the casualties that happen during conducting the HV testing, safety precaution needs to follow. With that, the apparel used while testing is crucial, for example, wearing hand gloves, safety glasses, and safety helmet. Moreover, the experiment should be understandable before conducting it, so there will be no accidents in obtaining the desired result. Not only that, the guidance from the professional also need to be taken into account, as the HV testing is a risky test. The HV testing was conducted under 2 conditions, which are wet condition and dry condition. Hence, a suitable testing area is essential for avoiding any casualties. That's all from us. Thank you.